Welcome to Virtual Cadet College and good morning to you all. Hope you all are fine at your home. Dear cadets, you have to follow the preventive tips for your safety. Firstly, wash hands with water and soap or sanitizer at least 20 seconds. Avoid contact with sick people. Don't touch eyes, nose, or mouth with unwashed hands. Don't eat raw food, thoroughly cook meat and eggs. Avoid contact with animal products. Due to corona pandemic, our regular classes are not taking place. So now I am here to take your class virtually. I am Abu Said, lecturer, Department of Mathematics, Virtual Cadet College. In this class, I am going to discuss statistics from chapter 17 of your book. Learning outcome. After the class, you will be able to explain cumulative frequency, frequency polygon, and ogive curve. Explain data by the frequency polygon. Draw ogive curve. Now, ungrouped data. Ungrouped data is data in its original or raw form. The observations are not classified into groups. For example, the ages of everyone present in a classroom with the teacher is as follows: 3, 3, 4, 3, 5, 4, 3, 3, 4, 3, 3, 3, 4, 3, 27. This is ungrouped data. This data shows that there is one adult present in this class, and that is the teacher. Ungrouped data is easy to work when the data set is small. If the data set is small, then it is easy to work. Otherwise, not. So this is ungrouped data. Now, group data. In group data, observations are organized in groups. For example, a class of students got different marks in a school exam. The data is tabulated as follows: the mark interval 0 to 20, 21 to 40, 41 to 60, 61 to 80, 81 to 100, and number of students 13, 9, 36, 32, 10. This is group data. This shows that how many students got the particular marks range. Group data is easier to work with when the large amount of data is present. Here, the amount 100, total amount 0 to 100. That's why when the data is large, then group data is easier to work or to solve problems. Now, frequency. Frequency is the number of times of a particular observation occurs in data. Class interval. Data can be grouped into class intervals such that all observations in that range belongs to that class. Class width, upper class limit minus lower class limit. Cumulative frequency. Cumulative frequency is obtained by adding all the frequencies up to a certain point. Cumulative frequency is obtained by adding all the frequencies up to a certain point. For example, temperature in Celsius 6 degree to 8 degree, here frequency 11. 9 degree to 11 degree, here frequency 13, and 12 degree to 14 degree, frequency 7. Now cumulative frequency, here first frequency 11, here 11 remain 11, cumulative frequency is 11. Then 11 plus 13, is equal to 24. This is cumulative frequency. Then 24 plus 7, that means 31. In the same way, we can write this. So cumulative frequency is the sum of the frequencies. Firstly, frequency 11, then 11 plus 13, 24, then 24 plus 7 is equal to 31. In the same way, we can find cumulative frequency. Now let us try to solve some problems, then it will be clear to you all. Here given that the marks obtained in English by 40 students in an annual examination are given below. Make a cumulative frequency table of the mark obtained. Here 40 students marks 70, 40, 35, 60, 55, 58, 45, 60, 65, 80, 70, 46, 50. In the same way, 65, 46, 76. This is given question. Now solution. Here range of the data. We know range of the data is equal to highest numerical value minus lowest numerical value plus 1. Here highest numerical value is 90 and the lowest numerical value 35. That's why we can write 90 minus 35 plus 1. That means 55 plus 1 is equal to 56. This is range. Now let the class interval be 5, then the number of classes 56 divided by 5, that means 11.2 or 12. Taking the immediate next integer when class interval is fractional. Now, hence the cumulative frequency distribution table of the class interval of 5 will be as follows. Here mark obtained. Mark is start 35 and the last mark is 90. But the number of classes 12. That's why we can write 90 to 94. Now mark obtained 35 to 39. Now this range, within this range, the frequency 2. So cumulative frequency 2. And 40 to 44. Within this range, the frequency 2. And 45 to 49, the frequency 5. And 50 to 54, the frequency 3. 55 to 59, frequency 5. 60 to 64, frequency 7. 65 to 69, frequency 6. In the same way, we can write this number. Now, the cumulative frequency. We know the cumulative frequency means the sum of the frequencies of the next numbers. That means frequency 2, here 2, frequency 2, cumulative frequency 2. The first number remains same. Then 2 plus 2, that means cumulative frequency 4. Then 4 plus 5, that means 9, cumulative frequency 9. Then 9 plus 3, that means 12. Then 12 plus 5, the cumulative frequency 17. Then 17 plus 7, that means 24. This is cumulative frequency. And 24 plus 6, that means 30. And 30 plus 5, 35. 35 plus 1, 36. 36 plus 1, 37. 37 plus 2, 39. 39 plus 1, 40. This is cumulative frequency. And this table is called cumulative frequency distribution table. Cumulative frequency distribution table. In the same way, we can find or write cumulative frequency distribution table. Now, discrete and continuous random variables. A variable is a quantity whose value changes. A discrete variable is a variable whose value is obtained by counting. Remember this thing. A discrete variable is a variable whose value is obtained by counting. For example, sum of the students present. Here we're counting this number of students and number of red marbles in a jar, number of heads when flipping 3 coins, students' grade level. This is the example of discrete variable. Now, a continuous variable. A continuous variable is a variable whose value is obtained by measuring. For example, height of students in class, weight of students in class. Remember these things when the continuous variable then obtained by measuring and discrete variable obtained by counting. Remember these two things. And time it takes to get to school. Now frequency polygon. The diagram drawn by joining frequency indicated points opposite to the class interval of indiscrete data by line segment successfully is a frequency polygon. Again, I repeat, the diagram drawn by joining frequency indicated points opposite to the class interval of indiscrete data by line segment successfully is frequency polygon. When we solve some questions, it would be more clear to you. In class 8, we have learned how to draw the histogram of discrete data. Here, how to draw frequency polygon from histogram of indiscrete data we will be put for discussion through example. Draw polygon of the following frequency distribution table. Here class interval 10 to 20 and mid 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70 to 80, 80 to 90. This is given class interval. Now midpoint. Midpoint means 20 plus 10 divided by 2. That means 30 divided by 2, 15. In the same way, 30 plus 20, that means 50 divided by 2, 25. And 40 plus 30, that means 70 divided by 2, 35. In the same way, we can find midpoint of the class interval. And the given frequency here 8, 10, 15, 30, 45, 41, 15, 7. This is our given table. Now we draw polygon from this table. Here, histogram of frequency distribution is drawing taking each square of graph paper as 10 units of class interval along x-axis and each square of graph paper 5 units of frequency along with y-axis. The midpoints of the sides opposite to the base of rectangle of histogram are identified, which are the midpoints of the class. Now the fixed midpoints are joined. The endpoints of the first and last classes are joined to x-axis, representing the class interval to draw the frequency polygon. This is our frequency polygon. Now let us clear. Here along x-axis, this is class interval, and along y-axis, this is frequency. Remember these things. Along x-axis, this is class interval, and y-axis, this is frequency. Now, this is our histogram. Our given data 10 to 20. Then frequency 10 to 20, then frequency 8, and 20 to 30, then frequency 10, and 30 to 40, frequency 15. This value putting the graph paper, then we can write this 10 to 20, then frequency 8. That means here 10 to 20, that means 8, and 30 to 40, frequency 10. This way we can put in the value here, then find the midpoint here. 10 and 20, the midpoint 15, that means here, and 20 to 30, that means midpoint here, and also midpoint here, and these are the midpoints. Now we joining these midpoints, then this diagram are called frequency polygon. Remember one more things, the endpoints of the first and last of the class are joined to the x-axis. When we draw polygon, remember these things, the endpoints of the first and the last of the classes are joined to the x-axis. This is our frequency polygon, and this is histogram. Now another question. The frequency distribution table of weights in kg of 60 students of class 10 of a school is given below. Here weight kg, that means 46 to 50, then frequency 5, 51 to 55, frequency 10, 56 to 60, then frequency 20, 61 to 65, frequency 15, 66 to 70, frequency 10. Now draw the histogram of the frequency distribution table and draw the frequency polygon of the histogram. So first we draw histogram of this table, and then frequency polygon of this table. Now solution. The class interval of the data in the table is discrete. Here 46 to 50. Here start 51. That means 51 to 50, 55. Again here start 56 to 60. That's why this data, this table are discrete table. If the class interval met, then the class interval met in discrete. The table will be the given table here, class interval 46 to 50, 51 to 55, 56 to 60, 61 to 65, 66 to 70. And the indiscrete class interval, that means here 0.5 minus or adding 0.5 adding, then this table will mate in discrete class interval. Here given 46, now we will start 45.5, that means 0.5 minus, and here also 0.5 plus, that means 55.5. Then here 55.5, 0.5 minus, and here 0.5 plus. In the same way, we can write this indiscrete class interval, 45.5 to 50.5, 55 to 55.5. In the same way, 65.5 to 70.5. And the midpoint of the class, that means 50 plus 46, that means 96 divided by 2, that means 48. And 55 plus 51, that means 106 divided by 2, that means 53. 60 plus 56, that means 116 divided by 2, that means 58. In the same way, we can write 63, 68. And the given frequency 5, 10, 20, 15, 10. Now let us draw a histogram A histogram has been drawn taking each square of graph paper 5 unit of class interval along with x-axis and frequency along y-axis. Here class interval along x-axis and frequency along y-axis. Here class interval start 55.5. That's why here start 55.5. Then the frequency 5. That means 5. And when the class interval 55.5, the frequency also 5. 55.5, that means frequency 5. Again, when frequency class interval 50.5, then frequency 10. That's why we can write here 55.5, the frequency 10. Here 5 and 10. These two frequencies are remaining here 50.5 and 50.5. That's why here these 2 points. In the same way, we can put in 60.5. 60.5, that means the frequency 20. 60.5, that means frequency 20. Again, the 60.5, the frequency 15. That's why we can write 16.5, that means frequency 15. Now, the class interval along x-axis has started 45.5, and the broken segment have been used to show the presence of previous square starting room from the origin 45.5. This is our required histogram. Now we can try to draw a polygon. The midpoints of the opposite sides parallel to the base of rectangle of the histogram have been fixed for drawing frequency polygon from the histogram. Previously, we draw this histogram. Now we find the midpoints. Here, this is the midpoint. This is the midpoint. And now joining this midpoint, then it will be polygon, frequency polygon. The midpoints have been joined by the line segment to draw the frequency polygon shown in the adjacent figure. That means this figure. If we joined the midpoints, then this histogram or this graph will be made frequency polygon. The midpoints of the first and the last rectangles have been joined with x-axis. Remember these things. The midpoints of the first and last points. Last and first point and the end points of the line segment joining the x-axis must be joining of the x-axis. Then the frequency polygon will more attractive, show more attractive. Now another question. The frequency distribution table of marks obtained by 50 students of class 10 in science are given. Draw the frequency polygon of data without using histogram. Here given class interval 31 to 40 and frequency 6, 41 to 50, frequency 8, 51 to 60, frequency 10 in the same way given this data. Now solution. Here the given data are discrete. Here you see the data here in point 40 and the here stating point 41. That's why we know this is our discrete data. So it convened to the draw frequency polygon directly by finding the midpoints of the class interval. So the midpoint of the first class interval 31 plus 40 divided 2, that means 35.5. In the same way, we can find at the midpoint 50 plus 41, that means 91 divided by 2, that means 45.5. In the same way, we can draw this table. Then we draw the frequency polygon without histogram. Here class interval along x-axis, here class interval, and y-axis, this is the midpoint. The polygon of the drawn by taking is square graph paper 1 unit and midpoints of the class interval along x-axis, taking each square of the graph paper of 2 units and frequency along y-axis. Here the midpoint of the graph here, the class interval of the midpoint is x-axis and frequency y-axis. Here the first midpoint is 35.5, then frequency 6. That's why we can write 35.5 frequency 6 and 45.5 frequency 8 and 45.5 then frequency 8. In the same way we find these points, and after that we joining this point, then this is the frequency polygon graph. Now cumulative frequency diagram or OZIP curve. Cumulative frequency diagram or OZIP graph is drawn by taking the upper limit of class interval along x-axis and cumulative frequency along y-axis after classification of the data. Again, I repeat, cumulative frequency diagram of OZIP graph is drawn taking by upper limit of class interval along x-axis and cumulative frequency along y-axis. Now, the frequency distribution table of the mark obtained by 50 students out of 60 students is as follows. This is class interval of mark obtained 1 to 10, then frequency 8, 11 to 20, frequency 12. In the same way the data is given. Draw the OZIP curve from this frequency distribution table. Now, solution. The cumulative frequency distribution table is given here, given class interval and the frequency. Now we know the cumulative frequency means the sum of the frequencies. That means first term remaining same, 8, 8, then 8 plus 12, that means 20, then 20 plus 15, that means 35, 35 plus 18, that means 53, 53 plus 7, 16. This is cumulative frequency table. Firstly, we draw a cumulative frequency distribution table, then we draw a OZIP curve. Here, the OZIP curve of cumulative frequency data that is drawn taking each square of the graph paper of 2 units of upper limit of the class interval along x-axis. This is the upper limit of x-axis. That means here the 1 is lower limit and 10 is upper limit. So the along x-axis is upper limit 10 and the cumulative frequency 8. That's why we can write here 10 and 8, this point, and here upper limit 20, then cumulative frequency 20, then 20, cumulative frequency 20. In the same way, the upper limit 30, the cumulative frequency 35, then 30 and the cumulative frequency 35. Here 40, cumulative frequency 53. Here 40, cumulative frequency 53. In the same way, we can write 50, the upper limit here 50, the cumulative frequency 60, then 50, then 60. Then join these points. This graph is known as OZIP curve or cumulative frequency curve. Now this is your homework. The following are the marks obtained in mathematics of 50 students in class 9 in a school. Here given data, this data are given. Then question number A, what is type of the given information, what indicate frequency of the class distribution, make frequency table taking appropriate class interval, draw histogram of the data. That's all for today. If you have any query, you can ask that in the comment section. Lastly, I would like to remind you the most important thing in this critical situation, you must stay home and keep yourself safe. Stay fine. Thank you.